Hello everyone, my name is Akarsth Kumar Singh from National Taiwan University. Today I present our research topic, a two-phase AI-driven approach to automated construction planning using small language model. This work addresses a significant gap in construction informatics by developing a domain-specific AI models for activity sequencing and missing task prediction. Our research is motivated by the critical industry problems. According to the recent company reports, 70% of the global construction project experiences delay or project overrun, resulting in 1.6 trillion in annual losses. The primary causes identified is poor planning and scheduling. A project complexity and scale increase technical and traditional method planning become insufficient and leading to sufficient financial losses, increase the safety risk, project failures, and this represents a substantial research opportunity in construction automation and AI in application. Our motivation is to massive industry problem begins with understanding its root causes. What causes that 1.6 trillion is losses? A two critical failure domain is like first one is a planning failure, like unclear work background structure, missing task dependencies, unclear task definition, poor resource planning. And second was scheduling failures, wrong time estimates, no buffer time, and poor coordination. Our research scope is focuses primarily on planning rather than scheduling, as our literature review shows scheduling has received extensive research attention, while planning remains under address in the AI and construction informatics literature. Research shows the several approaches with limitations, deep learning and graph models, effective for sequencing but require a large labeled dataset, limiting practical deployment. Domain-specific language models shows the potential but lack the sufficient fine-tuning for construction-specific tasks. Prompt engineering underdeveloped, affecting the consistency and generalization in construction application. BIM NLP integration also enhance the planning capability but face the data integration and structural challenges. These studies established the foundation but reveal the significant gap for practical implementation. The three critical gaps emerged from our literature analysis is manual labeling for unseen project data types and generic model limitation leading to inconsistent construction specific output and data privacy concerns, external model deployment. Our researchers address these gaps through locally deployed domain specific models. So our objective is like to develop the intelligent construction planning work sequence that reduce the manual efforts and enhance the accuracy through the automated task extraction and the dependency optimization. And our research contribution is like a CI model and CAS model. CI model is for the automated extraction of task component and CAS model is sequence optimization and missing task prediction. And also the input phase, we have a phase schedules, incomplete description, incorrect sequence schedules will give the output of the detailed schedule complete description and construction sequences by when the end user input the research schedule. So our methodology consists of multiple steps. First steps is data collection and pre-processing, in which we take a good quality of one historical schedule, underwent the systematic cleaning and mapping, create a structured training data. Then second step is a prompt engineering. We develop a structured prompt techniques and learning the approaches to optimize the model interaction. And then third step is instruction fine-tuning, like we use a small language models 7 billion to 9 billion parameters received from domain specific training construction tasks. And then the fourth step is evaluation framework, like we employ the multiple matrices like precision, recall, and F1 score for extraction task, and BERT score for semantic similarity and human. And for the human expert comparison for validation, we use the inference. The systematic approach ensure the reproducibility and significantly ignorance regards the schedule. For result and discussion of the phase 1, we did the experiment 1 for related to the prompt engineering evaluation. Using the GPT-4 Omni, we tested a structured prompt technique like COT chain of thought few shot achieved the highest performance with the 504 correct prediction from the 800 samples. And for the experiment 2 model fine-tuning, we fine-tuned the model significantly outperformed the prompt engineering like Mistral's 657 correct from out of 800, and this is the statistically significance that the fine-tuning model achieved the 20 to 35% percentage point improvement over the base model due from prompt engineering and demonstrating the value of the domain specific training. You can also see the performance comparison from the fine-tuning open source model and the closed source based model for prompt engineering for construction information extraction. Like in the fine-tuning, open source consists the 80 to 83% accuracy with the minimal variance of less than 4% performance gap, and the closed source model from prompt engineering 40 to 1464% accuracy with the high variance up to 35% of the performance gap. So our qualitative evaluation shows the distinct output characteristics like base model of the verbose unstructured and response, unstructured and response incomplete information extraction. Our fine-tuned model output like concise and structured extraction with complete component identification. Example shows for the first floor column shuttering also work have our model correctly identify all the 5 components, location, object, task, EPC types and work domains, while the base model missed some critical classification. And this demonstrate the improve the semantic understanding of the construction terminology. In the phase two result and discussion, BERT score evaluation comparing our open source model against the closed source baseline. We consider the GPT-4 Omni as a baseline user reference, as since it's a closed source model, its precision is 89, recall is 87, and F1 score is 88%. And our best open source model is a Mistral 7B, which precision is 71 and 72 recall, and F71 is our F1 score. And other source models like Llama and Gamma achieve the consistent 66% to 67 range. And research significance, while the GPT-4 Omni serve as our performance ceiling, and our open source model Mistral 7 billion parameters model achieve the highest strong performance that companies can deploy locally, maintaining the data privacy while delivering the reliable sequences. We also did the evaluation from the BERT similarity evaluation over a 500 plus samples, comparing the open source model against the closed source baseline. GPT-4 Mini again be as a closed source model baseline, which achieve a 91.59 mean similarity to expert sequences, and our open source model like Mistral, Llama, and Gemma. Mistral give the best performance 81.43 similarity, and research significance like while this closed source 4GPT-O mini baseline achieve 90% similarity to human expert, our best open source model Mistral 7B model reached the 81% similarity, demonstrating that also the same the local deployment and captures a substantial construction domain specific knowledge while maintaining the data privacy and avoiding the dependency again. So this is also the validation through the expert comparison, like example one in intra-domain domain sequencing. Our model correctly insert the column framework between the reinforcement and also the understanding the construction process dependency. And example two, inter-domain sequencing for finishing to MAP transition. Our model maintain the logical uh, task progression within the domain while correctly transition between the work types and showing the sophisticated domain knowledge. And through these examples validate that our model understand both technical dependency and the logical flow patterns in the construction. So our research make a three significant contribution, like first for the methodology, like first two-phase framework combining the information extraction with the sequence optimization using small language model, and second was technical, like demonstrating that domain specific fine-tuning outperform the large language general model for construction tasks, and also the third, the practical, they develop the deploy model that maintain the data privacy and while achieving the near experts performance. And these contribution advance the both construction informatics and domain specific AI research. For the immediate research opportunity, we have automated labeling pipeline, develop the prompt based strategy to reduce the manual annotation requirements. Second was the multi-agent evaluation, like implementing the small language model as quality judge for output assessment, and also unified model architecture like single model capability for handling diverse project types using the document only input, and long-term vision like fully autonomous construction planning sequence for with integrated quality control and privacy preservation. And these are the references. We acknowledge the support from National Science and Technology Council and STC from Taiwan, and also thank you for all both co-authors for giving more insights in this research. And we are welcome for the question and discussion. And you can also contact me through my mail ID. Thank you so much for listening.